Again, and welcome to our first webinar, which is called Dayton Slug Control. My name is Mojmir Kucera, and I'm sales manager of Dayton Progress. We will speak today about Slug Control System, SlugKeeper, and a little bit about Dayton Progress Company. I am here today with Jeff DeCore and Oliver Knobl. Hello, guys. How are you doing today?
Doing good. How are you?
Hello,
fine.
everybody. How are you?
Thank you. Fine. Jeff is the president of DTC Product Corporation. We are going to hear a little bit from Jeff on his perspective on the metal forming industry and specifically learn about the product which is called the SlugKeeper retention machine. Oliver is a product manager of Dayton Progress, and he will try to explain us today something about Dayton Slug Control, which is the method of reducing the risk of slug pulling. But first, let me show you a video about Dayton Progress, about a brief history about our company and who we are. So,
who are we? We are specialists in stamping solutions and the industry leader in the production of manufacturing metal stamping tools. Dayton Progress delivers punches, die buttons, retainers, and other tooling products to metal fabricators since 1946. Dayton Progress is part of these following brands: Danley, IEM, Lamina, and Lemco. Each brand has its own history that complements the overall value offered by Dayton Progress. Lemco, the eldest in the Dayton Progress family, began in 1917 as the Lake Erie Metal Products Company. Lemco serves major industries including canning, electronics, automotive, appliance, plastics, computer, and specialty items. The flagship product is the Rotainer, a precision-designed ball cage that minimizes tracking. Danley, incorporated in 1923, revolutionized manufacturing with a standardized guidepost, die set. Danley's interchangeability method, for the first time, made it possible for the die designer to lay out their die with absolute certainty that they would fit in the Danley die set specified. Danley IM continues to set the standard for die and mold components. Lamina began as a lamination die manufacturer in 1938 and has since evolved into exclusively manufacturing die and mold components. Precision-machined bushings, guideposts, wear plates, and cams comprise the core products and also hydraulic motors and equipment products. Dayton Progress has been a subsidiary of the Misumi Group since 2012, a global manufacturer of configurable components and standard components for special machining, factory automation, and mold die. This global corporate structure means that tool makers and operators can rely on the fact that the required components are available everywhere, no matter which norms and standards they follow. Since 2003, Misumi has been represented in Europe by the European subsidiary Misumi Europe GmbH. Located in Frankfurt am Main, it allows us to react quickly to our customers' demands.
okay, this is the end, and that was a short, history about Dayton Progress. And now we see in the video that we have many products in Dayton Progress, but today we will speak about just about the slug control system. It's a punch and die. It's the core products of our company, and we start with Oliver, and which takes around 10 minutes, and then we will continue with Jeff. So let's jump to this. Oliver, now it's your turn.
Yes, thank you, Mojmir. As already mentioned, we are coming now a little bit to our core business, what is punch and die. And as mentioned before, the following section will a little bit focus on the various methods to systematically remove slugs from the perforated zone and prevent the upcoming slugs during the withdrawal of the punch. However, before we dive into that, let's explore some technical aspects of that process in general. And typically the perforating process can be divided into the following 6 steps you can see here on that slide. And I will try to step on these 6 steps bit by bit, addressing also why the slug may tend to be pulled back up with a punch. So on this slide, you can see the first step that is called impact and elastic deformation. Here you see illustrated the punch, the component, and the die. The punch hits the sheet for the first time, and the entire system stops briefly until all the clearance is removed from the system. And yeah, this initial impact creates a shock wave in the punch. The shock wave travels through the punch in the up direction, in the opposite direction to the punch direction, and it results in the first elastic deformations in the components. In the next step, known as penetration and plastic deformation, the punch continues to penetrate the material of the component, and the material fibers stretch a little bit, exceeding the material's yield point, and that this is causing the first plastic deformation. You can see some roundings in the cutting zone and bending of the slug. And this bending creates a small vacuum between the punch and the slug. One reason for the later on upcoming. On the next slide, in the third step, called shearing, the materials, like the word already says, the material's shear strength is exceeded, and the material shears at the punch and the die edges. The cutting surfaces are formed on the part and on the slugs, and the cutting edges, which converge on both sides, also forms the first cracks. The next step, break and snap through. The strength in the remaining cross-section is now very low, and the propagation of the crack continues until the material breaks. The surface of the fracture is diagonal to the surface of the material, and at that break point, another shock wave passes through the punch, and this time in the opposite direction. In the subsequent step now, the retraction of the punch, the direction of movement of the punch is reversed. A stripper plate ensures that the sheet metal part remains in its position and is not pulled up by the punch during retraction. And depending on the material and the cutting perimeters, the clamping of the sheet metal on the punch varies in strength. The relative movement between the punch and the sheet metal strip causes wear on the punch and smoothing of the cut surface. In addition to other influences, which we will discuss in a moment, the same parameters have an effect on how much the slug bends, and the already mentioned vacuum forms between the slug and the punch. And last but not least, the spring back. Once the punch is now completely out of the perforated zone, both the component and the slug experiences a spring back, and the cutting surfaces, depending on the cutting parameters, have a burnished portion and a rough portion. And additionally, a corresponding burr has formed. Springback causes the resulting hole to be slightly smaller, and the slug created is slightly larger than the punch cross-section. So now, having covered the perforating process itself, let me provide a brief overview of the influences that promote the upward movement of the slug and the measures that have largely been established to prevent this. The reasons for upcoming slugs can be like you can see here: excessive cutting clearance, adhesion to the cutting edge due to a suction effect, or if you use excessively viscous lubricant, or also lubricant with a high resin content. and the burr formation on the slugs due to the dull cutting edges. Of course, countermeasures can be use of low viscosity lubricant if possible, and of course, timely regrinding of the punches and dies. And in addition to that aforementioned options, various measures have been established in the practice. The first three ones, ejector pins, slug control, and suctioning, we will also discuss during this webinar in the upcoming slides. And in addition to that, there are also some geometrical countermeasures like reducing the tip surface or shear angles on the tip, or also pre-embossed nipples to reduce the surface on the slug. Yes, like I already said, we will now talk about the first three ones, so ejector pins, slug control, and suctioning. First of all, our so-called jack tool at Dayton Progress, it's an ejector pin, and yeah, the ejector pin is a small spring-loaded pin producing a defined distance from the punch. And after the punch creates the hole and the slug breaks away from the perforated zone, the pin pushes the slug off the punch. Like you can see here on that slide, the entire system consists of the ejector pin itself, the spring, and a threaded pin that preloads the entire system, and an air hole on the side of the punch is introduced on the shank, leading to the inner cavity where the Dec Tool components lie. This air hole is very important to prevent the formation of a vacuum between the slug and the punch tip. On the upcoming slides, there will be like a small animation where the process participants are shown. Here, the punch with the air hole and the ejector pin, the component itself, and the die. The punch hits the sheet metal, the ejector pin is pushed back, and the internal spring is compressed. After that, the punch produces the desired hole and the slug is pressed downward into the die. And finally, the spring relaxes, pushing the ejector pin back to its initial position. The slug is ejected from the punch tip. The next slides show another way to facilitate the secure removal of the slug. It's called suction. An exhaust unit is integrated below the die, creating a vacuum in the waste channel. And the incoming air in the exhaust unit generates a vacuum below the perforated zone, pulling the slugs downward and away from the punch. The third method I would like to introduce here is the so-called slug control. We will go a little bit deeper in that subject now. Here, small grooves are introduced into the inner side of the die button. Number, depth, and the length of that grooves depend on the hole diameter, material thickness, its yield point, and also the cutting clearance. These grooves create small protrusions on the slug. I'm always saying they are looking like very small ears, and as the grooves run at an angle to the die surface, as you can see in the picture, the slug twists and jams in the die, and so the slug remains in the die and is not pulled up by the punch. In the subsequent stroke, the slug is transported downward by the next slug, forming a stack of slugs, which can become quite long. And so in some cases, so-called slug breaker plates are used to shorten the stacks after a certain length. And in the following animation, you will see how this system works, and maybe it will also help you to understand it a little bit better.
Who are we? We are specialists in
Sorry for that. It's here. Sorry.
You can see the system working, and you can see the punch coming from above, making the desired hole. And as you can see, the slugs are turned around into in the die button, and you can also see these little ears on the side. Of course, for a better view, I have cut it here the die button so we can see inside. In this case, we have 2 grooves in the die button, and yeah, so you can also see the stack of slugs here.
Okay, maybe I have one question for you, Oliver. We only can see round holes on your slides. Is the slug control also applicable on shaped holes?
Yes, absolutely. Of course, when you have shaped holes, you will not experience the turning of the slug, but with that grooves that are installed with an angle in the slug, it will clamp inside the die button, and it can be controlled, stacked in that die button.
Okay, thank you very much for your presentation. It was excellent. Thank you.
Thank you.
And now we have the SlugKeeper slug retention machine. Maybe before I will play the video short video about SlugKeeper, about you, Jeff, maybe you can tell us something, a few words about the machine, please.
So the slug retention machine is a portable unit that you can take to the die and grind in your slug retention groove. Similar to what you saw in the last video, you would grind a groove at an angle, let's just say 5 degrees to the left, 5 degrees to the right. And by grinding the groove in, that creates the resistance of the slug going into the cavity. Those 2 grooves create 2 little bumps on the slug, and as it travels down, it follows those tracks, creating resistance, keeping the slug from pulling back out.
Yeah, okay. Thank you for these words. And I will show the video now.
In less than 5 minutes, you can take the SlugKeeper out of the case, use the microscope to be able to zoom in on the opening, grind your slug retention groove into the die opening, and be back in the press, up and running in no time.
Okay, that was the video. And maybe, Jeff, you can tell us a little bit about how you came up with the idea for SlugKeeper. And of course, you can speak about success you've had getting this machine into stamping industry. And maybe you can tell us, why do stampers need this technology?
So a little bit about me. Me and my brother own a company called Dec Tool. It's a die building company. And back in the day, we would build dies, ship them around the United States, get that dreaded phone call of slug pulling. Obviously, Dayton Progress has a great slug retention bushings and stuff, but sometimes you can't do it in every opening just due to cost, due to the design. You can't fit an insert in. So we had to come up with a better way of keeping a slug from pulling. You ship a product, a tool down in Georgia, get a phone call, slug pulling. It's expensive to have it shipped back to add slug retention. So we developed and designed this machine to put the grooves in. Did some testing here. We build about 50 to 70 dies a year at Dec Tool, different material thickness for different industries. So during that time, we were testing the machine that we came up with in different diameters of wheels, different depths, different angles to see what seemed to work the best. One time I actually went out to a customer and brought the machine out because I didn't want to ship the die back. It was too expensive. And they were like, wow, where'd you get that? We need one of those. And that was kind of that eye-opening moment of, we have something here. So we worked on the patent, worked on fine-tuning the design of it, adding the microscope, monitor system, and then just from there, we patented it pretty much worldwide, and it's taken off since then.
Mm-hmm.
Some of the companies that have purchased it, we'll just name a few of the large companies: Ford, Molex, Temple. Basically, this can be used in every industry. whether it's on a turret press or a brooder press, high speed, or standard punch press. This will eliminate slugs from pulling in all types of material: stainless, HSLA, regular carbon steel, brass, copper. We have not found any issues of not being able to hold a slug. The nice thing about this machine is you can put it on the die, grind the grooves in, go to the press, try it out. Any issues, the machine's small enough, you can put it right in the press. It's 7 inches tall without the monitor. And you can grind a few more grooves in if you want. There's micrometer adjustment, allowing you to put the grooves in the exact depth you need. The head will pivot 5 degrees either direction to give you the exact angle you need to control the slug.
Okay. Okay, thank you. Thank you for that. Now we can discuss, now it's time for questions. If everybody who is looking at us, please write your question into the comment box if you want. And I have one question for both of my, guests. The question is, so does the customer have to specify the angle, depth, and length of the grooves of the slug control, or are there some tables in which these values or parameters can be read off? So maybe Oliver, begin, please.
Yeah, from Dayton Progress point of view, I can say that if you order a die button with our alteration XSC, that means that in the die button will be installed the slug control. You will get defined by your information you give to us, like the clearance and the sheet metal thickness and such things. We will do an optimum of slug control grooves in the die button. Of course, and here I see really the connection between the slug control of Dayton Progress and the SlugKeeper from DDC. It's just the flexibility you have. Of course, our optimum we have in the die buttons is experience and also mathematic and physical yeah, how can I say, formulas behind. But in reality, you will see maybe you need another groove in the die button, and if you have the SlugKeeper, you can just do it, and you do not need to reorder them at Dayton Progress at this time, and next time you know the best way.
Okay, thank you. And Jeff?
Yeah, so with the SlugKeeper, if you purchase the machine, there's a book that comes with it. It's 1 page. It pretty much talks about the different hardness of material you're stamping, which determines the angle that you put the head at. So the machine is designed to go from 0 to 5 degrees, depending on the material hardness you're stamping. The depth that you go into the side is determined by the material thickness that you're stamping. And there's a micrometer on the machine to control the depth. So once you touch off with the grinding wheel, you set the micrometer to 0 and go in the depth required for the material thickness. There's also 4 diameters of wheels that come with the machine, both in diamond and in borzon, so you can do carbide or tool steel. And again, those diameter wheels are based on material hardness, or material thickness that you're stamping. So the thicker material will have a larger diameter wheel, creating a larger bump on the slug as it goes through the die cavity, which creates more resistance and able to hold that larger slug in.
Okay, thank you for this. And we have some questions from our viewers. The first one is from, it's here. So we have seen the ears of the slug control system in the slug. What about the perforated hole? Will it be seen some mark in the edge owing to the grooves? It's probably for you, Oliver.
Yeah, of course, the animation we have seen before to make it better viewable, they have very big ears and very big grooves. In reality, the grooves are very small. just to hold the slug down. And yeah, you will see it a little bit also in the perforated hole. But this is always the compromise you have to do on the other hand, but it's very small.
So what you will actually see is the underside of the strip will take shape to your die button.
Yeah.
So you'll have the round hole with two little bumps. And as Oliver said, you're only going in 1,000s, 2,000s, 3,000s. So those little bumps you'll see on the undersurface, but the inside shear and break of the strip, you will not see any marks, only on the undersurface. And the top side where the punch enters will take the shape of the punch, so there'll be no issue there either. So the shear surface is exactly the shape of the punch. The breakthrough side is the shape of the bushing, only at the bottom of the surface of the strip that touches the bushing.
That's it.
Okay, thank you for this. And we have another one. What is the maximum angle we can make a groove? What is the best?
So on the slug retention machine, the maximum angle is 5 degrees. I do build dies for a few customers, and one particular customer requests 7 degrees. I have found that 5 degrees to 7 degrees does not make a difference. We've actually gotten them to change their spec on their print to 5 degrees. The minimum angle is probably more important. The minimum angle is 2 degrees. You have to have some type of an angle to cause the retention for the slug to stay in, because that creates the resistance.
Okay. And Oliver, do you want to say something?
To be honest, I need to go back to our manufacturing to find out what would be the maximum angle we can do. But in the end, I think the maximum is at least never the one we need. As Jeff mentioned before, it is always depending on your process, and so I think the maximum will be not the one you need.
Okay. Okay, so we have another question here. Look at that. Is this true? Is it true this only works to 10% die clearance? And maybe another from the same is this. We run a lot of aluminum panels, 10% die clearance.
So I've actually built a lot of dies for aluminum, and we use all different clearances. We've built, whether it's steel, aluminum, brass, copper, HSLA, stainless. The punch and die clearance, we've used slug retention from 5% up to 20%, and it works. What we have found is obviously more clearance, the more tendency you have to pull a slug, less tonnage it takes to blink the slug. You start with 2 slug retention grooves. As we say in the SlugKeeper, 2 is good, 3 is better, 4 is best. So we usually start with 2 slug retention grooves. And if you're pulling slugs, figure out what you used last time, maybe go a little deeper, check the slug itself, check the strip, see how it all looks, add 2 more, maybe a little deeper, change the angle, and your slugs pulling will stop.
Okay. And Oliver, do you want to say something?
I have nothing to add here, I would say.
Okay.
Thank you, Jeff.
Okay. Okay. So no questions now. So thank you very much for your attention. Thank you, both of my guests. And I hope that we see you each other the next time. And yeah, again, thank you for attention.
Well,
Have a nice
thank you.
day.
Thank you. And let everyone know that they can buy the slug retention machine from you guys at Dayton Progress.
Absolutely.
Yeah.
Thank you all.
Yeah.
Thank you.
Bye.
Take care.
Bye.